So you have your function fx in ln, then function gx in exponential function. Find your composite gf inverse. Hence, evaluate the value. Alright, so we have to answer this first. Without answers this, then you skip to this, then you will be losing your marks. So you answer your question part by part. Which one come first, we answer that. Which one come after, we continue that part. Alright, so we don't terbalikkan dia punya sequence. Alright, so one more question is, when you look at this log modulus, don't misunderstand that this is modulus function together with log. No. You have to understand that log function, not every x can be defined in log function. Apa yang log bawa tu, not every x can be accepted. Alright, x only can be more than 0, then that log function can be accepted. Why they're putting modulus? They're putting modulus to make sure for every x inside here, they can make the log function. So that is not modulus function in your point of view. You just look at this only. So you understand when you're having the log, when I put like this, means I want to x accept everything. Without this, when I put log, x only accepts 0, more than 0. Negative cannot. It will be log negative undefined. Make error, undefined. I just make sure the x to be substitute every function so that later you substitute negative 2, later you have value 2 to be substituted, it will be no problem. That's all. So that is the motive of log. For putting apa yang log bawa ni, modulus. Okay. Okay, so for first, we have to find out the composite function before we get the inverse. G fx. G, substitute your fx, ln. But can I just put in bracket? If you want to put in bracket, then you understand that every x here is accepted, then also okay. No problem. You want to follow with the modulus, also same, but you have to understand this is modulus to make sure the x valid for the log functions. Okay, so substitute your hx, then substitute this in gx. How to substitute means the place of x here is substituted by this log. E negative ln 2x plus 3 plus 3. So most of the students, when they see e to the power of ln, they just cancel. Wrong. E to the power of ln x, yes. Not for e to the power of 2 ln x, not to the power of e negative, you cancel. What is this? Your coefficient you haven't simplified with using the properties of log. When you have a coefficient in front of the log, what should you do? You move back to the power. So which means that this 2x plus 3 is in the power of negative 1. Then only you want to cancel your e ln, baru betul. So in the final here, actually you are getting a rational function. So rational function, we get same to the denominator because we want to continue for inverse. Therefore, 3 times 2x plus 3. So simplify this, 6x. 3 times 3, 9, plus 1, 10. So just remember, when you want to cancel your e ln, make sure the coefficient clear. Pull back. Use the properties of the log. Pull back. It will be the power of your. So why suddenly from modulus change to bracket? As I have noticed you before, the modulus just to make sure it can accept every value of x. When I already cancel the ln, so that is not a modulus function there. It's just 2x plus 3. Alright, or not, you misunderstood this is ln function. No. Okay, so when you come to a rational function, you have to get sim to the denominator become a single fraction. So like this, we haven't simplified yet. You have to simplify until one denominator, simplify until the last stage. Then only we continue for composite inverse. To find composite inverse, GF inverse. So we use composite method. GF inverse x will be equals to x. Same concept with f inverse equals to x, because that is what we finding previously is f. So now it's gf. So composite method will be gf inverse equals to x. What's mean by this? We substitute gf inverse into the function of gf. Means the x here will be substituted by gf inverse. So 6x plus 10, 2x plus 3. So tempat x ni akan diganti dengan function gf inverse. So what do we need to do? We simplify to get out this gf inverse. So multiply up, cross multiply, you get 2x. Then gf inverse plus 3. Then collect back your composite function, minus 2x, move it to the left hand side. And factorize out your gf inverse. You have remaining 6 minus 2x. So finally you get your inverse function. So that will be our first part of the question. Hence, evaluate substitute value 2.